All right, so today we are going to be talking about modernizing your applications to be compatible with, to optimize, just to run on AWS. My name is Donovan Brady. I am the Director of Solutions Architecture here at Logicworks, and I'm going to be teaching you all about modernization strategies. So to go over what we're going to be talking about, first I'm going to start with a high-level overview of technical debt, what it is and why you should definitely be concerned with this mountain, why you should consider modernizing and refactoring your application, why and how AWS promotes modernized architectures. I'm then going to talk about some of the fundamental principles of a modernized architecture and then show you some common modernization strategies. Then I'm going to wrap up with a case study of one of Logicworks' customers who we've actually helped migrate to the cloud, modernize their applications, and accelerate their business in the process. First, I wanted to talk about a little bit about Logicworks and who we are. Logicworks is a leader in cloud migration and managed services. We do pretty much everything that you could imagine related to cloud. We do professional services, optimization work, migrations. We do database migrations and optimizations, app refactoring, and obviously the managed services. On the top right here, you can see some of our customers. You'll notice a common theme. They are all mission critical, highly available, hyper compliant customers. That's because Logicworks is a hyper compliant partner ourselves. We are annually audited for PCI, HIPAA, HITRUST, SOC 1, SOC 2, and ISO 27001. And then by nature of our customers, obviously, we need to be GDPR compliant. So we've got the whole shebang. And again, I am Donovan. I have been a professional gigging musician since age 6. I was born in New York, and I love video games in general, but 90s video games for sure. I think the soundtracks are the best, the stories are the best, and you could pretty much catch me playing one of those games. So let's talk a little bit about this concept of technical debt. Now, I'm sure a lot of you have heard about it, you're familiar with it. If any of you are software engineers or developers, you're very familiar with it. But technical debt is the accrual or accumulation of complications or challenges that you have faced in your application due to a reliance on a specific piece of technology or a specific component of your application. It usually accumulates due to shortcuts during the development process. Let's say you wanted to get to the market really quickly with this new feature, but to do it the right way would have taken months, and you needed to get this out in a week. So you cut some corners. You have dependencies on legacy or outdated systems. You have been deployed in a data center for the last 10 years, and now you've got this ancient SQL server running server 2000, and now you're kind of tied to that, and it's going to be hard to move it, so you just kept it. Over engineering, on the complete opposite side of that spectrum, you really wanted to make this thing perfect, and you over engineered it, but now it's resulted in a bunch of complications because of other dependencies that are interconnected in your application. And finally, I'd say one of the biggest ones is lack of standards. Companies grow at extremely fast rates today. And as the teams are growing, as the developers are growing, it's hard to convey the standards of your architecture or coding practices across all team members. So a lot of it becomes tribal knowledge, and then you end up having multiple different snowflakes as parts of your application. All of these create really bad technical debt. And as you can see on this graph on the right, technical debt tends to grow in an exponential function, right? Why is that? Because it compounds on each other. I use this word accrual because it really does accrue like interest rates. It compounds. And if I have one thing and then another thing is, if I have one issue and then another issue is based on that issue, compounded, they make a much bigger issue, right? You can see here that technical debt and growth have an inversely proportional relationship. As you are trying to grow your company and focus on more features, more feature requests or things that might help your customers, the more time you have to spend on fixing technical debt is going to take away from that time of those future projects and those features, right? More time is spent on your infrastructure management than the development of your applications. This also becomes very expensive. What ends up happening is you have these monolithic environments, you have one giant server that has everything on it, and that's costly for a number of reasons. It could be costly from an AWS standpoint. You know, this giant server could be a $20,000 a month server, right? It could be costly in terms of the engineering time required to manage it. There are many different components of why it could be expensive, but it is. Why is this concerning? You can see that this picture in the middle here is pretty much me in my development days. You're just around, you're surrounded by technical debt. You're like, oh my God, what do I do with this? It's so clunky. I can't make the changes that I need to make. It's frustrating. You just see stars the whole time, right? It's slow and inefficient, and you can't really do your job. It completely slows your growth, right? So I know all of you are thinking, Donovan, you've painted a very bleak picture about this thing called technical debt, but what do I do to fix it? How can I improve? What do I have to do from here? Well, one great way to combat technical debt is to refactor your application into a more modernized microservice-based architecture. Now, microservice has become a buzzword in the last few years, but I'd say it's one of those buzzwords that deserves all of the buzz. It is pretty much the overarching concept that ticks all the boxes of the WellArchitected framework. We're going to get into that later. And it provides a really strong foundation for you to grow your team, grow your application at scale without accruing a ton of technical debt, while also maintaining a modernized architecture and staying relevant in the market. What you do is you spend a lot of time up front developing or refactoring or rebuilding your application so that you save time in the long run. You don't have to spend on maintenance moving forward. You're not worrying about the server architectures and whether this thing is going to break if I make a change. And it's going to create a very agile practice for your developers so that they can continuously deploy and develop whenever they have a new feature request. They don't have to go through week-long deployment processes. The microservice-based architecture.
Donovan, why don't we do this? We got about 10 minutes left. I can see some of the bandwidth issues. Why don't you turn off your camera so we can hear you better and the picture doesn't tie up the bandwidth?
All right. Is that better? All right. I'm going to take that as a yes.
Yes, it's better. Sorry, I muted myself. All right.
No problem. You know what? Sorry, bear with me 1 second. I'm going to change my internet connection. Sorry.
I'll do this on the fly. So the thing I want to point out as we go through this is the need for using experts like Donovan, because when you've got this term like technical debt, do you modernize applications? Do you do cloud native design? There's a lot of architectural options out there depending on your user base, your regulatory guidelines. There's really not a one size fits all. Do you want to use open source? Do you want to use proprietary software? I mean, it's just difficult. And, you know, overlaying that is just all of the security considerations that you're facing when you do have a fundamental re-architecture. So as Donovan pulls up his presentation, I just want to emphasize that as you grapple with these issues, you want to make sure you're leveraging the combined expertise. The other commonality you see, and we heard that in Steve's security talk and Amber's comments on cloud health, all of these really cool companies are taking away a lot of the detail work like you don't have to worry about collecting data. You don't have to worry about collecting all these reports and formatting them correctly. You don't have to worry about, we're going to hear more from companies like OutSystems about low and no code. They're doing lots of this for you so you can work more effectively. Donovan, are you all set now? I can see your screen.
I believe so. Can you hear me?
Yes, we can hear you fine. So with regard to timing, Donovan, we'll go a little bit. I'd plan about another 10 minutes, okay?
All right, perfect. Just stop me if you hear me cutting out again. So we're talking about refactoring, we're talking about modernizing your applications, but how does this relate to AWS? Well, many times that applications become modernized or refactored, it lends itself really well to supporting that architecture on AWS, because AWS has a whole diverse set of services that are designed for this microservice-based architecture. As you can see here, they have services from pretty much every aspect of your environment. They have application-based services. They have code deployment services that I don't think are listed here. That's code commit, code pipeline, right? It allows you, oh, actually they're, nope, I thought they were down at the bottom. Code commit, code pipeline, they allow you to create CI/CD pipelines so that you can actually create that continuous integration while you're deploying or developing your code. And they allow for serverless based architectures. We're going to get into that again a little bit later as well. I wanted to talk a bit about this concept of the well-architected framework. Now, this is found in every one of the presentations that I have done for Angel Beat, which, thank you, Ron. We do a lot of them. These are great. But the well-architected framework are these 5 pillars of excellence that AWS has come up with, focusing on operations, security, reliability, performance, and cost optimization, right? In order for you to have a well-architected or modernized environment, we strongly recommend following the principles of all of these 5 pillars. If you follow only 4, you're probably doing all right, but in order for you to be well-architected and for us to certify and say, yep, this is a great environment, it has to tick all 5 boxes. Now you'll notice that those 5 boxes also coincide with the best practices and fundamental principles of a modernized architecture, right? When you modernize your architecture, you're increasing your flexibility by moving your operational overhead to AWS-based services, so you can spend time focusing on your application that makes you money. Your teams aren't responsible for managing infrastructure, because infrastructure is how you make your money. Your team is responsible for managing infrastructure because it is a necessary evil for you to manage while you build the app that makes you money. So let's offload that. Let's offload that to AWS so we don't have to worry about that anymore. You can deploy a CI/CD pipeline so that you can continuously deploy your code, improving the integrity of the application deployments. You can create different gateways with testing structures in it, and it overall decreases your deployment time and your time to market. It's very conducive to increasing your innovation, because the microservice-based architectures allow you to innovate on one component without sacrificing the availability or integrity of different components of the application. I can change configurations on the web server without worrying about how that's going to affect the database, because they're not both on the same server, right? I've isolated these 2 things, and I can scale them separately. I can develop on them differently, and they're going to be highly decoupled. It's going to decrease your cost. We don't need to provision peak anymore. Let's think back to that first slide that I was talking about, very expensive. $20,000 a month is not an exaggerated figure. There are some workloads that require that because they have a giant Oracle database or a giant SQL server that has licensing, but it's also got the web server and the application servers and everything built on that one server. And they're so highly coupled that it all has to be on the same server, becoming very expensive. But if I'm able to decouple all of those things and have a very, very minimal footprint of, let's start with one web server that's really small, it costs me $200 a month. Then I have a database on the back end, and the web server scales to meet the demand in real time. You're going to be looking at more like $5,000 a month than $20,000 a month. All of these improve your reliability because you're limiting the single points of failure. That's going to increase your resiliency. And since I can deploy this in multiple different places, I can deploy it across multiple different availability zones. That means I'm going to be able to load balance to multiple places, again, decreasing that single point of failure, and I can scale out one component if it throttles or meets a capacity limit. And finally, this concept of decoupling, it allows me to leverage the best tool for the right task, right? I'm not going to need to run a database on this giant server if I can decouple that and actually refactor it to a NoSQL database. I can run that in a serverless model, right? I don't have to manage the infrastructure itself. I can just write my code and have AWS do the hard lifting for me. Really quickly, I wanted to talk about the three different most common architecture patterns in these modernized environments. One is an immutable infrastructure. I'd say this is the gateway to a modernized architecture. You can create a pipeline to create AMIs that are golden. You don't need to make any manual changes to your long-standing infrastructure. You don't have to worry about making a tweak that's going to bring down the whole thing. If it doesn't work, let's just redeploy it, right? We can put different tests in place at different parts of the pipeline. It allows us to make changes at scale across all of our resources, and it allows me to make all my changes at code. The next step up, I'd say, would be containerization. You heard Amber talking about this a little bit before. This decouples our OS level dependencies, allowing greater developmental freedom. So I can deploy on Linux, I can deploy on Windows, and I'm really focusing on the technologies rather than what I'm handcuffed with at the operating system or the technology level, right? This also allows me to scale at a greater rate because I can scale the containers without having to scale the underlying infrastructure itself. And finally, if you're feeling really frisky, if you wanted to go all out, you'd refactor into a serverless workload, which I've talked about a number of times here, where obviously it's not, quote, serverless. It's not, there's something there on the back end, but you're not managing it. AWS would be managing it for you. And you can just worry about building your code. The code runs closer to the end user, it decreases latency, and you are more tightly coupled to the application code itself rather than the infrastructure capabilities or lack thereof instead. Finally, you're only charged for the server space that you use or the Lambda functions, for example, that you use in real time. So you're not paying for idle resources that aren't really running anything, but they're still accruing cost. Finally, I wanted to talk about ServPro. ServPro is a leading fire and water disaster cleanup company. They came to Logicworks wanting to migrate their 1,700 franchises to AWS, but the problem was they had one giant application, this monolith that I've been referring to, where all of their backend 200 applications had dependencies to this primary application. So you couldn't migrate one without migrating the others at the same time. So what did we do? We actually refactored their application and built it in a containerized EKS-based architecture with an Aurora backend database. That's all Amazon native tools. That allows us to scale that primary architecture and application. It allows us to be more flexible with our deployments, and we can do it cheaply. That also effectively decoupled the dependencies between that database and these backend applications. So we were then able to migrate these other applications to AWS in an immutable infrastructure pipeline, that first stage that I was talking about before. We were able to create a pipeline that was governed by AWS CDK that allowed us to migrate and deploy the applications and their data for all these 200 applications at the same time in real time with fresh architecture, with fresh infrastructure at every stage. So that's about it. I hope you all could hear me. Sorry about the bandwidth issues. But if you're interested in modernizing your application or migrating to AWS, please contact us. My name is Donovan Brady, I'm the Director of Solutions Architecture at Logicworks, and it's been a pleasure. Thank you.